In this section, I'm going to show you how you can create, how you can use multithreading, how you can use multithreading with Stream APIs. So in order to do that, I'm going to create a new class called Stream API Multithreading. I'm going to do a public static void main with it. Um, I am going to create a list of string to demonstrate how we can use multithreading with streams. So I would say arrays dot as list, and then let me just do a sample array. So I'm just naming them the elements 2, 3, 4, 5, 6. That way it would be easy to understand which element is being used under multithreading. Okay. So I have a list and I'm using this as an array list. Okay. So first thing, let's look at it without multithreading. Okay. In order to understand it better, let's do this. So list dot stream, and then what I'm going to do is I'm going to do a for each, and I'm going to simply do an s out. So if I do this, generally, so in streams, what would happen is the streams would process the individual items sequentially. So if you see here, it has printed from 1 to 10 in the same order in which the objects are there. So let me create a function, public static void, and let me name it run it now, and I am going to give it a object as probably. In order to see when individual thread is running, I am just going to create a date time, the local date time object, so that I can print at what time um, individual threads are running. So we will also print the time or milliseconds in which the thread was run. So millisecond, second, sorry, minutes, seconds, and then this is for milliseconds. I will do a sys out, and then local date time dot now dot format, and then I'm going to use this formatter plus this, and then I'll print the object. So here I'm simply printing the object. Now I'm doing a thread.sleep. So I can do that by thread.sleep, and I don't want to sleep it for a constant time, otherwise we would not be able to see the threads running independently. So let me do this. Um, create a random let me create a random object here so that I can put a random weight in each thread. That way we'll be able to understand that individual threads are running independently, and we'll also see the time for those. Okay, so I'm going to create a new object for random, and probably I'll do this new random, and then I'm going to get the next double, and the next double I'll multiply with 1000 so that I'll convert them, and then I think this function needs a long. Yeah. Okay, so basically what I'm doing here is I'm waiting for random milliseconds up to 1000 milliseconds here. I'll just add with surround it with try catch, and now if I do this, instead of just doing this, I can use run now and then put the s here. Okay, so even here there's no multi-threading. What will happen is for each and every object, this method will be called, back to back. So there's no multi-threading here. So I'll run it. So you see here, it is running for the first object, then for the second object, then for the third object. So you also see the difference in the milliseconds here, right? So it started when then the second was when there was 5 seconds, and then it ended when there was 10 seconds. So there's no multi-threading till this point. Now, I'm assuming that you already have some experience about the executor service. So with that assumption, I'm going to go to executor service. I'm going to create executors and then new fixed pools thread pool. I'm going to create a executor service with 10 thread pools. I'm going to do a sysout, and this time let's see with multi-threading. Okay, so this is simple. I can do list dot stream dot for each, and then I can take that object and push that object into the executor service thread pool. So executor service dot submit, and here this needs runnable, so I can do it like this, run it now, and then give that object. So what I'm doing here is using the stream API, I am submitting individual runnable interface into this executor service, and I'm allowing it to run for using the multi-threading. Okay, just so that it doesn't keep on going, I will shut down it, and I'll also do await termination. That basically, just to give you a quick idea, that basically wait for this much time until the thread is uh, thread is all the threads under that thread pool are done. So I'll just add exception. Now you would see here that the first chunk of code will run without multi-threading, and this chunk of code will execute this run it now function in a multi-threaded mode. So let me run it now. So you would see for the first code, it is without multi-threading, so it's running with 10 um, individual items. And then if you see with multi-threading, what happened is it started at 3 and it ended at 3 seconds itself, because we have done a multi-threading. If you see here, it took 4 seconds, and here to do all that, it just took not even 1 second, because we are doing a multi-threading. Also, if you look at the threads, the first thread which with the string s3 got completed first, then the one with 1, 6, 4. So there is no specific order uh, of completing these individual threads. But at the end, we see an exit code. That's because we have shut down the executor service gracefully. So here you see we have a thread pool of 10. You can also play around by making it 5. If you do the thread pool of 5, what it would do is it would start from 1 to 5 first, and then 6 to 10 later on. So if I run it now, you would see some arrangement in terms of some sequence. So if you see with multi-threading, it ran with 1, 2, 3, 4, 5 first, and then 6, 7, 8, 9, 10. Coincidentally, it is in exact sequence, but if you see here, this is still in multi-threading. So it starts at 22nd second and it ends at 22nd second. If I run it again, I would see some random order next time. Just some numbers which would jumble up. 1, 2, 3. So if you see, the third thread completed at the 5th position. So it took a bit longer, but then this is basically showing us that the threads are independent. Again, it completed within 1 second for us because it was multi-threaded. So this is how you can do multi-threading using Stream API. There is one more thing in Stream API, which is again for multi-threading, but it is not a very much recommended way to do that. Stream themselves give us a function which says you can process the stream parallelly. So here what we have done is, if you see, we have explicitly done the multi-threading, but you don't, if you really have a very big list of items which you want to process and you want to process them parallelly, you can simply do this. So you can say, okay, you can say that list.stream.parallel, and stream itself will uh, do the parallel processing. Okay, so to parallel stream, this is though not a recommended way to do because in Java documentation you would find many places where they would say only use it where you really have a very big list of stream, and then the size which is generally preferred in the documents is that a list which is having less than 10,000 or 20,000 items in it, we should not use parallel streams, because this is kind of still settling, a feature which is still settling in Java 8, but we can still, just for knowledge, we can still use it and see how it works. So now we have three sections. One section which is running without streams. The second section which is where we have multi-threading, but we are doing explicit multi-threading using streams. The third section, the code-wise, this is the simplest line for multi-threading, but the words of caution there is use it very carefully. So let's run it and see what do we get there. So the first section is running without multi-threading. The second section ran with multi-threading. The third section ran with parallel streams. So now if you see, stream itself has done parallelism for us. So it started at 47, it ended at 47, and it was really fast. So if you see this, it took 1 second for us with explicit streams, but this one even didn't took uh, probably 200 or 300 milliseconds. That also for sure depends on the wait time, the random wait time gets generated here, but the parallel streams are really fast. You get, however, you get less control in terms of how many thread pools how many number of threads you want to do that and all that in just this very basic parallelism which Steam provides. But still, this is still a use case for your knowledge. Okay, so this is how you can do multi-threading using Stream APIs. Okay, that's it for this section. Thanks for watching.